Okay, so one thing you're going to notice is that I use different types of recording formats throughout this class, depending on what I'm teaching. If it's something that benefits from you seeing me write things out, video, we'll use that. So in this case, to review baseline comparisons, I'm going to use this whiteboard I have here and work out some problems with you. So there are two main things I want to point out with these baseline comparisons. So they're trying to make 2 points. The importance of a comparison group, right? Your experience alone, while it might, provide some insight into future research, isn't enough to draw conclusions. So you always have to have this comparison group. So to help illustrate this, I have this example that has come up in class before, where people have discussed how, well, when I shower, if I go to sleep after I shower, I tend to get sick, right? That's that person's experience. When I shower, I go to sleep with wet hair. That's key, right? It has to be wet hair. Not an issue for me, but for some of you it might be. They get sick. Like, that's a claim, right? Anytime I do this, I get sick. Well, one thing that's missing from this situation is a comparison group of people who had the same experiences as you, that you've had throughout the day, that have been exposed to as many bacteria and viruses and stressful situations and health situations as you have throughout the day. But the only difference is this person showers. That's supposed to be a shower thing. And this person does not shower. Now, if this person doesn't get sick and then this person does, well, maybe there's something to it. But if they both end up getting sick, then it had nothing to do with showering. It had nothing to do with the wet hair. Now, you wouldn't do this only with 2 people. You would have maybe 100 people and 100 people here, right, who would do the showering thing and 100 who would not shower, and then you would compare them. And then you could draw conclusions, right? The point being, you cannot draw causal conclusions just based on your experience. We tend to do that as humans, right? We tend to think that because I experienced this, that's how it is. We need this comparison group here to see, well, what would it look like for people who didn't shower? What would it look like for people who didn't have this one experience, and does it still connect to that outcome of getting sick or whatever it might be? Now, another point they make is, well, okay, let's say out of, you report that 20 times I showered, you remember 20 times you showered and you got sick right after. The issue is that you don't remember, and we don't keep track of, the times you did shower, went to sleep with wet hair, and did not get sick. Let's say that was 80. So even though there was more times where you didn't get sick from the same action, what we're paying attention to is the times we did get sick, right? So we need all the data. So there's these 2 components. We need the comparison group that links to not drawing conclusions based on our personal experience, and we need all the data. We need not only times that you did get sick from going to sleep with wet hair, but the times that you did not get sick when going to bed with wet hair. Now let me go ahead and move down a bit. Well, actually, no, I think I'm good right now. I'll just draw a line. So in these baseline comparisons that you have here, table 2.1, 2.2, 2.3 in chapter 2, they're making this point. You need all the data and you need a comparison group, right? These are the 2 points they're making. Now, in your exam, I will give you problems like this. I will give you problems where you have this data And I will ask you, well, based on this data, does it look like bleeding patients might be effective? You might have your own personal belief about that, but we're just basing it on the data. Now, keep in mind that these numbers are hypothetical, so don't take them seriously, but I still want you to get in the practice of working these out and remembering that when you see this on an exam, you have to focus on what the numbers are and what the question is asking. So let's go ahead and do table 2.1. So I'm going to redraw that. I'm going to say bled. I'm going to say not. So that means not bled. Recovered. And died. So these are the numbers they have for the first one. 10, 80, 40. Now keep in mind, normally we might just have that, right? You could imagine a situation where somebody might say, hey, I've bled, excuse me, I've bled people when they were sick and 20 people recovered. That sounds great, but you want to know how many people were bled and did not recover, and how many people had the same sickness, were not bled, and what was the recovery rate for those people? In this case, let me change the color. That's this group, right? The people that were not bled. So let's work this out. Okay, so if I asked you, well, does it look like this approach is effective, right? Are people who are being bled, are they recovering more than the people who are not being bled? So the first thing you want to do is focus in on the horizontal line, or where it's being focused on the people who did improve or showed benefits. In this case, it's people who recovered, so keep that in mind. And you're comparing these two groups, people who were bled and people who were not bled. People who received the treatment, or the experimental group, and people who did not, or the control group. So let's go ahead and work this out. 20, remember, we want recovered. You want to put that on top. That's what we're dividing. And in preparing, one mistake I made is I put 80 as a denominator, or what the 20 is being divided by. That's incorrect. You want to make sure you're dividing by the total number of participants. That's 100, right? We had 20 here, 80 here. Essentially, we're saying 20 of these participants, 20 out of the 100, recovered. And then you want to look at the people who were not bled, right? Of the people who were not bled, 10 recovered, and this was out of 50. Remember, we had 40 here, 10 here. So then we have to work this out to see, well, what was the recovery rate for the two different groups? Now, simplest way to do it is to divide 20 by 100 in this case, so divide the top number by the bottom number, and that would give us 0.20. Take a moment, work it out in a calculator, and you'll see you'll get 0.20. Then multiply it by 100, and you'll get 20%. Now, keep in mind your calculator might just show 0.2, which is fine. But then when you multiply by 100, you should end up with 20%. So this is a recovery rate for people who were bled. 20% of the people who were bled recovered. Now let's try this out. So 10 divided by 50 will give us 0.2 as well, times 100, same thing. So if I gave you this problem, you would say, well, it looks like there's no difference, right? You wouldn't be able to draw any conclusions based on this data, because the people who were bled, people who were not bled, they had similar recovery rates. In fact, I would say based on this data, if I gave you this question, you would say, well, it looks like it's not more effective than doing nothing, right? Because it's the same recovery rate for people that were not bled. Okay, so now let's look at table 2.2. Let me move this over a bit. So table 2.2, I'm going to go ahead and draw out the same numbers. So you have, actually I meant the table. So bled, people who were not bled, people who recovered. I should have made that table bigger. And died. So the numbers are pretty much the same. So notice that these numbers here are the same. One cell is changing. The people who were not bled and died, that number changed. So here they're showing you, look at how much changing one cell changes the overall outcome of this. So let's go ahead and do this. So for people who were bled, let me label it this time. Actually, bled, not bled. So people who were bled, 20 out of the 100 recovered, and we worked this out before. We know this is 20%. And people who died, 10 out of the 11, right? Because we're looking at the total, right? 10 plus 1 is 11. 10 out of the 11 recovered. Whoops. So when you divide that, it'll give you 0.91 times 100 will give you 91%. So the recovery rate for people who are bled is 20%, and for people who are not bled was 91%. So in this case, the evidence suggests that actually it looks like people who are being bled might be recovering at less of a rate than people who are not bled, meaning that being bled actually might even have a negative outcome, right? It's not just about whether it helps or not. It actually looks like it's definitely not helping, because only 20% of people who were bled recovered, whereas people who were not bled, this comparison group, right? You can think of it as a control group. They recovered at 91%, much higher, right? Much higher than people who were bled. So in this case, you would conclude it's definitely not effective. If anything, it looks like it's causing harm to our participants. So let's do this last one. Let me zoom in this way a bit so you can see it better. So in this case, we still changed one number. Let's see how this works out. We have 20, 10, 80, 490. These are people who were not bled. Participants were bled, recovered, died. Okay, so just to show you there's different ways you can organize your information, let's look at people who were bled. 20 out of 100. Remember that denominator has to be the total. And that we know again gives us 20%. And for the people who are not bled, you're going to see a difference here. 10 out of 500 recovered. So this will give you something like 0.02. Let me move this over a bit. Oh, actually no. Let me just do it this way. Times 100 will give you 2%. Right? You don't want to draw it out this way. I just did that to make it fit. So 20% compared to a 2% recovery rate. Now in this case, if this was your data, you would say, well, based on the data, it looks like people who were bled were more likely to recover or recovered at a higher rate than people who were not, right? Because that number is 2%. So in this case, you would say it looks like the treatment is effective. So keep in mind, you're focusing on the numbers, you're not getting too lost in determining, well, is this actually true? I just want to see and make sure that you can work these type of problems out. Also, keep in mind, you might also find an issue in terms of how many participants you have in each group. Here, you have 100 for people who are bled. Here you have 500 participants who were not bled. So ideally, you do want those comparison groups to be equal in size, right? So you should have about 500 who were bled, so you can have equal numbers to the participants who were not bled. That is a valid point for those of you who have taken research methods before, but don't get lost in that for these type of problems. In these type of problems, you're working out these percentages based on what I'm asking for. Am I asking for recovery rate? Am I asking for improvement? Am I asking for how many people actually got sick? Make sure you know which one you're looking at. You put that number related to the variable of interest or the term I'm referring to on top, and then divide by the total. And then you compare these percentages. My suggestion to you is work out examples using these tables. So table 2.1, 2.2, 2.3. Change the numbers and see, can you work out these numbers, right? Let me give you another example that just happened right now. Meaning, let me give you some information about this. I went downstairs to get some water because you might have noticed earlier in the video, it sounded like I was choking. My throat was a little dry. So I went down for some water, and my wife said, well, have a spoonful of honey. That helps with a sore throat. So that's a claim, right? So just to give you an example, again, I would just take these tables here and change the numbers and work those out. But let's think of this, right? So honey, no honey. Felt better. That's not negative, but felt neutral, meaning no improvement. So let's say you recruited people who had a hoarse voice from public speaking, lecturing, recording videos, right? And you have this claim that I think honey helps with that. Helps with it when you have a sore throat, when your throat is tired out. So okay, let's test this. And let's say these were our numbers. Actually, let me change that last number just to make it an easier number. Okay, so we're comparing people who had honey to people who had no honey. We're looking at this improvement in the voice, right? The voice feeling better. And let's look at the honey group first. So 25 felt better out of the 100. When you divide that, you'll get 0.25. Multiplied by 100 gives us 25%. So this is the honey group. No honey. Nope. 5 out of 20. Now out of 15, remember we're adding these. So that would give us 0.25 times 100. This is 25%. In this case, I would say, well, it looks like there's the same improvement for both groups regardless of honey. So there's no evidence that honey is better or worse, right? So this is an example of how you can apply it to your life, how you can look at what you'd actually have to recruit participants. So, but this is how the data might look, at least it's the way you structured the data to evaluate claims that you've made or that you come across. You need to know, what does a comparison group look like? And you need to know all the times it didn't work. Not just the times it worked. Not just the times that honey worked, made your throat feel better, but also the times that you took honey and you felt no difference. So if you have any questions, feel free to reach out. This can be a little confusing, but the math isn't beyond what any of you all can do, right? It's pretty straightforward, but at the same time, if you need a refresher, reach out, come to office hours. We can work out a few more examples.